In this video, we're going to talk about a digital twin adoption story. Digital twins are really complicated data solutions. Typically, they take a long time to build, a long time to adopt, scale up, and there's a lot of failures in the process. We're going to use a real use case here to describe how to build, deploy, and scale digital twin solutions very rapidly. As a background, the digital twin solution we're going to talk about is a solution we've built with our partner Precision Drilling. It's a rig asset digital twin solution. What it means is that it's monitoring all the rig assets like pumps, top drives, generators in real time, and also analyzing historic data to understand how the assets operate and predict failures, improve efficiencies. So this is a screen capture of part of the digital twin that shows you the asset status at high level. And it also gives you ideas on smart alarms and smart alarm history, and also a timeline view of all the events that's happening on the rig. This is another view of a different section where it shows a particular mud pump, how it's working, how to predict asset component lifetimes using AI models behind the scene, and a digital logbook app to record any maintenance component replacement events, as well as timeline view of events for this particular pump and other type of information. So as we can see, the solution is very complicated. In addition to these pages, there's pages for the top drive, for the power generators. There's pages that automatically calculate savings from the predictive maintenance solutions. There is ways to automatically email all the rig managers on their daily summaries, activities, etc. And the architecture of the digital twin is also quite complex. It uses data from multiple different sources, from EDR, which is the electronic drilling recorder data, essentially data coming from the drilling equipment, and external sensors such as vibration sensors, temperature sensors, current sensors, and maintenance logbooks that are the maintenance data recorded by the field teams. Data can come from the cloud, from the edge, and this data usually are pretty dirty, so they have to be cleaned, validated, transformed, contextualized, then they have to be combined to convert from time domain data into information data. And then the information data is used in AI models to generate the insights displayed on the digital twin dashboard. So today, this solution is already deployed at 101 rigs across North America, and it processes 25,000 high-speed data tags, which translates to roughly 2.1 billion data points per day processed, and 57 million database queries processed per day. So there's a huge amount of data the solution is processing. It's one of the most advanced and scaled up digital twin solutions in the upstream industry. And typically, a solution like this would take a long time to build and deploy. What we have done here is a process that enables very rapid development and adoption of the digital twin solution. So as we can see here, the project was approved in January 2023. At the time, there was a blank sheet. And within just 2 months, in March 2023, the first version of the mud pump digital twin solution was completed. What the team decided is to pick a single asset class to build first. And the reason we picked the mud pump is because it requires a lot of maintenance. There's a lot of components in the mud pump that need to be replaced frequently. So a digital twin solution would be very useful for the field to keep track of component replacement. And once we built the initial version of the solution, we asked 2 rig teams to try the solution for 1 month. And during this 1 month, we iterated with a field team on a weekly basis. Every week, we asked for 1 hour of their time to get feedback. What do they like? What do they not like? What other features do they wish to have? And we were able to build those features, new features, into the solution within a matter of days. And then the next week's meeting, we asked for feedback on the changes. This created a lot of engagement and trust from the field teams. So after about a week, they really opened up. They were very excited to share all the features they want because they saw that those can be implemented very quickly. And by the end of the 1 month period, we figured out what are the features that are important to the field. The field gained trust in the solution, and they told us that this solution is to stay. Not only they started to use the solution, they were also excited about the solution, so they told other rigs. And those rigs started to call the Precision Remote Ops Center to request for the solution. So this is a bottom-up grassroots type of adoption. And by the time we got to about 15 rigs in June, that's just about less than half a year into the project, it was adopted at 15 rigs. And we start to collect the results on the digital twin in terms of the downtime reduction, non-productive time reduction, cost savings, and we saw the commercial impact was really good. So that encouraged us to continue to encourage rigs to adopt the solution. And by January 2024, within about a year's time, 52 rigs adopted the solution. And along the way, we didn't stop development. So as we see here in November 2024, we converted a simple model to keep track of component lifetime into a machine learning model. The machine learning model is much more accurate and is able to track the lifetimes of these components from day one they put in to the day they reach the end of life. However, the field didn't even realize there's a difference because the dashboard just tells the field when the components need to be replaced. Whether it's AI model or some other model is not seen by the field, which is intended because the field really doesn't care about what technology is used. They just need the result to be good. And so we continued the adoption journey. More rigs signed up for the digital twin. In June of 2024, we finished the top drive digital twin. And by September 2024, over 100 rigs adopted the solution. And we started on the generators digital twin. So as you can see, this is an organic adoption process, right? Precision did not push the digital twin onto the field teams. The field teams adopted voluntarily. And because of that, the solution is one that has proven to be useful for them. And another thing is that we didn't take on the entire solution with all the features at the start. We chose one asset class with a limited number of features, and we iterated with the field to figure out what are the features they want. Then we continued to build it as the field adopted the solution over time. So it is very important to understand that we have to be able to figure out what the field users want. That's what the solution is for. And in order to do so, we have to be able to iterate and rapidly develop So a rapid iterative technology and a methodology is very important for the success of this type of digital twin solutions. So this is an illustration of how a very complex digital twin solution can be adopted very quickly and achieve very good business impact to the customer. If you are curious about the technology we use to build very, very fast digital twin solutions, you can reach out to us, or we have a lot of material online, and you can read about our technology. Thank you.